I'm Mr. Anderson, and welcome to homework help for 2.7. All right, here we are going to graph an absolute value function. All right, if you recall, our the general form of an absolute value function is y equals a times the absolute value of x minus h plus k. All right, so the first step is to plot our vertex. All right, we want to plot our vertex. Well, the vertex has the coordinates of h and k. That's our vertex right there. That's our vertex, h comma k. So we take a look at the equation that we are given here, and we see we have an x plus 3. Well, our general formula says an x minus h. Okay, so you can kind of think of it, well, the only way we can get a x plus 3 is if h was negative. So h has to be a negative 3. Let me clean that up a little bit. H has to be a negative 3. So this is x minus a negative 3 gives us x plus 3. All right, so our vertex is negative 3 is the x coordinate, and then the y coordinate is negative 1. All right, since we have a plus k here, this with the sign is always going to be our y coordinate. So y coordinate for our vertex is going to be negative 1. All right, so let's go ahead and plot that. All right, we have negative 3. 1, 2, 3. Negative 3 and down 1. All right, right there. There is our vertex. And recall, the vertex of an absolute value function is the point of it where both rays meet, whether it's upside down or whether it's right side up v. All right, it's that point. It's either going to be the lowest point of the function or the highest point of the function. Okay, next step. Let's plot another point. All right, so we pick out an x. Just choose an x. Choose an x and make it close. Make it close by. Choose an x close by. All right, so this x was at negative 3 here. That was a negative 3, and we want one that's close by. So we choose something like negative 2 or negative 4, maybe this 1 here. When you start getting further away, then this point might be further away on your graph. So it makes it easier if you just choose an x that's close by. All right, so let's choose this negative 2 right here. All right, we choose x, and then we're going to find out what y is. So we're just plotting another point. All right, we need 3 points in order to make this this v looking function. So our second point, we chose negative 2. Let's see what y equals when we plug in a negative 2. All right, so y equals, we go back to our equation here, 2 times the absolute value, and we put in negative 2 plus 3 minus 1. All right, well, negative 2 plus 3, that's going to be just 1, and the absolute value of 1 is still just 1. So we have 2 times 1 is 2, and then we still have to subtract the 1. So y would then equal 2 minus 1 is 1. All right, so when x equals negative 2, y is going to equal 1. All right, so let's go 1, 2, y is going to equal 1 right there. All right, so we plotted our second point. All right, now the third is we can use the symmetry of this absolute value function. We know we have half of our absolute value function right here. All right, we have right there. We have half of it. All right, and we know that this half is going to go up this way, just like this. It's going to be a mirror image, right, at the line of symmetry. That's a vertical line right at the vertex. All right, so right along here, we're going to have a line of symmetry, and it's going to be just a mirror image of this ray right here. All right, going up this way. All right, so we can visually inspect it, and we see, okay, well, we stay the same height on the graph, and we moved one to the right, then we'll have to move one to the left, right? And that will be our third point. So we could visually inspect it and choose, or let's say we plot the opposite point. We plot the opposite point. And that gives us 3 points, and we are able to draw this graph. It's kind of sloppy there, but we're able to plot that. Now the other way we could plot that point is we could choose another x. All right, but we want it to be on the other side of the vertex this time. All right, this vertex was at x equals -3. All right, so we want it on the other side. Maybe choose this -4 right here. We could choose any of these other numbers here, but they just might get to be really far away from where our graph is, where we have our origin. It just might not be very handy. All right, this is our x, and this is our y-axis. All right. So let's choose this -4 here. Excuse me. All right. We plug -4 into our equation. We get y equals 2 times the absolute value of -4 plus 3, and then -1. All right, which is -4 plus 3 is a -1 inside absolute value bars. All right, we still have to subtract 1. All right, well, -1 inside of absolute value bars, that's just 1. So we have 2 times 1, and then we're subtracting off 1. All right, well, 2 times 1 is 2, minus 1 is 1 again. All right, so at -4, 1, 2, 3, 4, y would equal 1. If we put a -4 into our absolute value function, we would get out a y of 1. All right, so this would be our second point. We already plotted it here. All right, we visually inspected it and used the symmetry of the function in order to plot that and make our line. All right, so we could have just used the symmetry, or we could have plotted a point on the other side of the vertex. All right, well, I hope that is helpful, and I will see you in class.